Hey, Raphael, how are you doing?
Very good. How are you? Did you have you continued working on the LVM stuff?
Uh, yes, but not as much as I would like.
Hmm.
We had the usual shuffle of developers around. So the guy who was working on the NVMe portion is on another project. So I'm ramping up another guy too, who's working on finish some of the LVM2 testing and getting that in place. So I wish it was a little, you never get it. It never goes as fast as you want, right?
Right, right.
Right. But yeah, it's coming along.
We should sync again. Are you coming to KubeCon?
Yeah. I'm gonna be there. Are you flying in?
Yeah. So
Perfect.
let's sync again on the LVM part and see, you know, how how aligned we are in the objectives for supporting virtualization.
Yeah, and the Topo LVM stuff. I've got another developer who's ramping up on the gRPC and looking at the agent that we use to do something similar. And I want to once he comes up to speed, get him looking at that project. I think it, I think there's synergy there that we could help exploit the merits of LVM2.
Okay. Oh, we have somebody is not able to join. They have the wrong
Ah,
link.
hey, Rafael, I was able to figure it out. Thank you.
Oh, okay, okay.
Yeah.
So that okay, good. Then we are all here, right? Or are we waiting for someone else in the
Oh, so
from?
do we have the SlateDB team here? I think today I think we do have is that Alex, right? Alex?
Yeah. Hey,
Yeah, so he has a quick topic. Can we just have him
yeah,
go
just
over
a,
it for a few minutes and then we can have the presentation on SlateDB?
yeah. You want me to just
Yeah, I think
he's not
looks like we already have enough people here. Yeah.
cool. Yeah, Marlo and I and also Abby run the batch working group for the runtime tag, and we were here to sort of, as one SIG to another, invite you to a discussion that we want to have around how to marry schedulers with storage, and in particular, how to anticipate where schedulers will want to run compute and how to get data to the places where compute will be running, or vice versa. And we've got a number of storage people, Hammerspace and Vast and Weka, and probably some others by that point, and along with a bunch of the scheduler type people like me and Marlo and Abby and a host of others. And hopefully we can all talk and come up with some plans for how to actually do this. So it's just an invitation. We're probably going to start those discussions on November 18th, just after KubeCon. But I wanted to come here and connect with you, or if you know of anybody who wants to have that kind of a discussion, how storage intersects with scheduling decisions, we would love to have you. So uh, I'm either Alex Gammon or Stacked Sacks on Slack. So you can reach out there, and there's a batch working group no, Slack channel that you can find us all in.
Yeah,
And
that's
that
great.
that
Yeah, it's a great topic. I think definitely we are definitely interested in this. Yeah.
Yeah.
Cool. Thank you. And I'll hold on for a few minutes. And Marlo is there. You may stay longer, but I have to run to another meeting shortly. So
That's
thank you
fine.
very much.
Do you mind if I add some content, Alex?
Yeah, totally.
This is specific to AI batch and training jobs, specifically training jobs, but also some amount of inference because a lot of it has to do with where is the storage located from a scheduling standpoint. Where is the storage located compared to where your compute is and what the cost is of moving that over.
Is this the, so I found this link here. Is this the working group? Is this
Yes.
the right one? Okay. So how is this related to this batch working group in Kubernetes?
So Kubernetes Batch Working Group is pushing forward changes within Kubernetes specifically. The CNCF Batch Working Group that we run is looking across the cloud native landscape. So it's not just in specific, the Kubernetes Batch is likes to work on Q, KUEUE, that project. Whereas we have representatives from Q and SCED-MD, Marlo, me with Armada, IBM at MCAD, we've got Unicorn, we've got Volcano, we've got there's tons and tons of batch schedulers, not just the one that Kubernetes is looking at to try and sort of push the jobs API forward and things like that. So we're at different levels.
Okay,
Yes.
got it. Okay, yeah, awesome.
Yeah. Thank you
Yeah.
so much. I'm
Thank
going to run, but I really appreciate you giving me a couple minutes, and I won't take any more of your time. Thank
Hey,
you.
no problem. Yeah, looking forward to deeper discussion in the future.
Thanks.
Yeah. Okay, so who will be doing the presentation for SlayDB?
Hey, I will be doing, I have Chris here
Oh,
as well.
okay. Well, let me stop sharing so you guys
Okay.
can share.
Okay, yeah. So, okay. Hey, can everyone hear me and see the screen?
Yeah.
Okay. Hey, I'm Vignesh. I'm excited to present SlateDB. I also have Chris here. Chris started the project, and it's been in progress for a couple of months, and we already have a few releases out. SlateDB, it is an embeddable database built on object storage. And what we are going to do today is look at some of the motivations and overview of SlateDB and architecture and roadmap. And after that, I will leave it for Q&A. Let's look at the motivation. Object stores are rising. We see that S3, Azure Blob Storage, Google Storage, all of these are enabling capabilities that's making new architectural paradigms possible, where the compute is stateless and the only state is stored in object storage. We see a lot of services that are getting built with this architectural paradigm. Examples are a Warp Stream, which is a Kafka-compatible streaming platform built directly on object storage. And Delta Lake is another example where it provides asset guarantees for analytical tables, and the state it stores is only on Cloud Object Store. There are several examples like this, and Chris had this tweet a couple of months back. The nice property about object store is that it's reliable, it's durable, and you can batch the API calls and increase the latency while keeping your cost low. This property is very appealing for a number of use cases, and 100 milliseconds is reasonable for a lot of use cases. So with that, we believe that the future, there will be a lot of these services built on object storage, and a key value store that is built natively with object store in mind is going to be very useful. SlateDB is that storage engine. And with that, we will get to the overview. Any questions so far? Should I pass? Okay, let me keep going. So what is LateDB? It is a cloud native embedded storage engine built on object storage. It is a in-process Rust library. It provides key value interface. All the writes go to object store directly. It's implemented as a log structure merge tree. These are some of the features. It has a single writer and it can support multiple readers. It provides snapshot isolation, additional things like pluggable compaction and transactions are in progress and should be coming in the next couple of months. I have put up some of the use cases that are here. Stream processing is a use case where the checkpoints and state can be stored in object store. Durable execution, data lakes, these are some of the use cases that we see embeddable library like this is useful. Let's get to the architecture. We are looking at an overview. I'm going to drill down into each of these boxes in the upcoming slides. There are essentially two layers. There is an in-memory layer and then the object storage layer. So we will get into each of these in detail. Essentially, the state is stored in object store, and there is a hierarchy of components that we access for serving the reads and the writes. With that, let's get to the next level, which is, okay, before we go to the manifest, let's look at what is in the state of the database. The state of the database, state of SlateDB is a set of SST files, and these files are stored in object store. And now we also need to know which are the files that compose the database at any point in time. And that is what we call as the manifest. The manifest is also stored in object store, and it is sequentially numbered starting from 0, 1, 2, and so on. We use the conditional write property of the object store to ensure that multiple writers don't step on each other. What we are looking at is how the files will be laid out in object storage. There are 3 directories. One of them is called manifest. It will have a sequence of files that show the logs that are mutating the database. For example, in this, we see 3 manifests, 0, 1, and 2. 2 is the current manifest. What is a manifest? A manifest contains the set of SST files that are currently part of the database, right? And there is val, write ahead log. We will get to that in the next slide. Compacted is where the SST files that are compacted will be returned. And the manifest file, it will have a pointer to, will have the names of the compacted files. So that's the manifest. And let's look at the writes and then what happens during the write. So when a write happens, there is an in-memory structure called write ahead log. It's a key value. The data is stored in val, and every flush millisecond that is configurable by the user, the val is frozen and it becomes an immutable val. And the immutable val is returned to the object storage. So you see that here a file called 73.sst is created, and the immutable val is in addition also returned to the mem table. And there is a configurable size called L0 SST size. When the mem table hits that limit, it's also written as another file inside the compacted directory. And after this compacted, after the file that ends with 6HS in this picture is written. The manifest is updated, and the manifest now will say that this particular file is also part of the data DB. Just before it writes, it freezes it so that additional writes can continue to happen on the mem table. And the frozen mem table is what is written onto the compacted folder. So that is the flow of writes on. There are two essential components. One is the writer, and then the second one is the compactor. We will look at the compactor in the upcoming slide. The writer is one of the components that is mutating the state in the object store, that's mutating the state of the slate DB. And this is how it does it, right? So to repeat again, it starts with val, and every couple of milliseconds, configurable, let's say 50 milliseconds or 100 milliseconds, it's made immutable, and that's returned to the object store. And at a configurable memory limit, the mem table is flushed to compacted folder. We will get to the read part. Before we get to the read part, I want to cover a little bit about caching. There are several.
Can I interrupt? Sorry.
Sure, yeah, go ahead.
I was trying to understand. So, because at the beginning you said this is in process, right? So all of this is
Yes.
happening in the memory of the process, right?
Yes.
And you said that you were explaining some sort of traffic light, let's say semaphores, to prevent concurrency, right, problems. So this is if your process has multiple threads, right? I'm assuming so multiple writes.
Yep.
Well, I have a question around: can you have multiple instances of the process working on the same database?
No, it supports single writer, so there can only be a single process that currently owns the writes. There can be multiple readers.
There can be multiple. Okay. So that's what single writer means. Okay, understood.
Yes.
Thank you.
Yeah. Okay. Any other questions?
Abhishek, do you mind muting? We can hear your keyboard.
So sorry about that.
Sorry.
Okay. Hey, let me get to the next slide. So caching. We looked at writes. We will look at reads. Before looking at reads, I'm sharing a little bit about caching. There are several layers of caching. One is metadata. These are things like which are the SSD files that are part of the DB currently, and then the index. The SSD file is split into multiple blocks. For each block, there is a key range that is also in the metadata. And then there is a Bloom filter. This metadata is cached, and there is a DB cache. I shared that the SSD files is a sequence of blocks, and each block is a sequence of key value pairs. The DB cache caches the blocks in memory so that reads can be faster. And then the next level of caching is at the disk level. So object store, all of the files that we write are immutable, and we split that into configurable chunks, and those chunks are cached locally. So they are cached locally on writes. So when there is a read happening, if we have to access the object store, we check the disk cache first, and if we get a hit, we serve it from there. So those are the layers of caching that we have. Now, this picture does not show the cache. I will talk through it. Reads happen in this order. There are committed reads and uncommitted reads. Let's talk about committed reads first. Everything in memtable is already persisted to object store, which means if the process crashes and comes back, we will have the data again. So that is committed read, and that starts with the memtable. And if you get a hit for the particular key, it returns it. If not, it goes to the frozen memtable, and then to the next layer in the LSM, which is compacted. It goes through the sequence of SST files in the L0. After that, there are a sequence of sorted runs. Each sorted run has a sequence of, each sorted run has a set of SST files, each SST file covering a non-overlapping range of key values. And that's how the reads work for committed reads, committed isolation level. It goes to the mem table, it goes to the frozen mem table, and to the L0 files, and so on. The L0 files keys are overlapping. Sorted runs keys are not overlapping. And the next slide is going to be about compaction. Compaction is a separate component. This component can run inside the same process as the writer process. It's designed to run as an independent process as well. This is one of the advantage of using object store as your state. This picture has a lot of things going on, but essentially the L0 writes or L0 SST files are written by the writer, and at a configurable interval, compactor is looking at the state of the database, which is the L0 files and the set of sorted runs, and it decides if a compaction is necessary based on some thresholds, and the compaction algorithm is pluggable as well. When it decides that a compaction is necessary, it picks a set of source sorted source SST files. It runs the compaction, and it either updates existing sorted run or creates a new sorted run. And after the process of doing that is it will read all the files, it will write new SST files, then it will update the manifest, and the manifest would say that this is now the state of the DB. Again, we use conditional writes to ensure that different processes don't step on each other. That is roughly what compactor does. The writer or the reader, to be more concrete, looks at the manifest. It can do a list operation on the object store to find out if there are additional manifests. And if there is an additional manifest, it uses that to find out more compacted, more optimized version of the SST files, and it switches to that for serving its reads. And if they are happening in the same process, if the compactor and the writer, then they just communicate through in-process message. So that is compactor. Here is an example usage. So this is, there are 3 steps that are going on here. It creates a storage using the object store crate, and then it creates the DB. It provides a couple of options. How often to flush, for example, is one of the options. And then it does a put. When you do a put, it waits on it. And that wait will complete when the flush happens. If the flush is configured to be 100 milliseconds, for example, it's going to wait that long. There is a write option where you can say that I don't want to wait for the flush to happen. Then it returns immediately. That's what we are looking at in the second chunk of code. And then you can also explicitly call flush, which will wait for the flush to be, which will complete the flush for all of the items. So that's roughly how the code would look like on the user part. And here are some of the things on the roadmap. TTL is coming, transactions is coming, snapshot isolation, range queries, and then finally language bindings. These are some of the things that are there in the roadmap. And this is everything that I had. I have a couple of other files open if we want to get into details about any specific things. I also have a snapshot of the contributor section to show how the community looks like and so on. We still have time, and I can drill into more details on any of the areas that you think is more interesting.
I have a question.
Okay,
If anyone, I've already asked one, so I was waiting for someone else to go first. But why? So we have a lot of key value stores, right? Of all kinds. What would be the advantage of using? Like, what is the use case for using this? Which, from what I understood, right, uses object storage as its own storage system, right?
Mhm.
Yeah.
Yeah.
And this
Yeah.
is really out of my ignorance, right? I'm not an expert on, this word. So if you can explain why one would choose this as opposed to a key value store that maybe just writes to disk, right, to block storage.
Sounds good. So this is an early project, and there are use cases. Here is one that I can share. Let's say that you are using a stream processor and you want a key value store. You could use something like RocksDB, and it will be writing to disk. And the process itself, the compute process itself, typically is considered to be stateless. So when it comes back, it by itself doesn't have any state. It needs to recover it. If you were to use RocksDB, and the disks are essentially ephemeral, right? And if you were to use RocksDB, for example, you would write to disk, but then you also will need to copy that to object store out of band yourself. That is a paradigm that some of the engines already use. If you use something like SlateDB, which is natively built for object store, it takes care of those aspects by itself. That is an advantage. So that is a use case, right? And I covered some of the properties that this enables us to do. For example, the multiple readers is a very nice property, which is you can have other processes that are doing snapshot isolated reads on the same key value store. Time travel is another advantage where you can have different snapshots at different point in times. I showed the manifests. Each manifest is essentially a snapshot of the database. You could be operating, you could have multiple snapshots of the same database at different point in times. So those are some of the advantages, and I shared a specific use case.
Okay. So you compare it with most of it RocksDB, like you don't compare it to, I don't know, something like etcd or these other software.
I think there are kind of like two architectural options to pick from with key value storage. One is like in process and the other one is remote, right? And so on the in process side, really RocksDB is kind of the main game in town. On the remote side, there are a bunch of different options for, TIKV and on and on. I think on the remote side, we are sort of not comparing ourselves to that because they're just very different in terms of, they're running in distributed mode and they come with a lot more operational overhead. One of the goals with SlateDB is to be very, very lightweight on ops. So we don't depend on anything except object storage. Versus even RocksDB Cloud, which if you want a persistent wall would require Kinesis or Kafka or something. So we definitely think of ourselves more on the like embedded local side. For etcd in particular, actually one of the things we were looking at, I think one of the guys from DataBen was looking at is Kind, which is an etcd compatible replacement. And he was actually looking at using SlateDB as a storage engine for Kind. And so I think etcd is not something that I would directly compare SlateDB with. I would more think of SlateDB as like something you could use to build something like etcd, if that makes sense. It's sort of at a slightly lower level.
Okay. Understood.
Do you have a deployment diagram? Maybe I missed it if you have that earlier in your presentation.
I don't have a deployment diagram. So it is an embeddable key value store, and in the process that it is embedded in, this is how it will look like. There is no deployment per se. It deploys along with your application.
When you say deploy with your application, like, yeah, it would be good to show like what kind of application, how an application uses this, I think. I'm just thinking that if you can add that, will be helpful. Some deployment
Oh.
diagram show how an application, let's say pod running Kubernetes using this, or how you imagine this is used.
Okay, sounds good. I don't have that right now. The best thing that and I can add it later. The best thing I have is the code, application code, and how the application code would look like. This is how the application code would look like. I don't have anything related to deployment specifically. I can take that feedback and add that later.
Okay, I think there's a question on how is this project related to cloud native? I think there's some specific questions asked in that issue that you opened.
Sorry, could you repeat that? I was reading the chat.
Right. So I think if you can explain more on how is this related to cloud native rather than just cloud, right? I know you mentioned this is can use this with S3. I guess I'd like to see more cloud native connection. You can explain
So
more.
can you give me a definition for what you think cloud native is?
I think there was a definition I need to find that definition, but CNCF has that definition. So normally when you apply for Sandbox, they have you answer that question, right? Then there is a definition by CNCF. So actually you find that somewhere. It is somewhere.
Because I'm a little confused by this, because like literally you can't run this unless it's in the cloud, and it is a building block to enable other infrastructure to be built on the cloud. So it's like nothing but cloud.
Yeah, that question, the sense of the question was the following: is a library a cloud native thing? Right.
I mean, I think that's irrelevant. We're building a tool to enable people to build cloud native infrastructure. That to me seems like it's an important component of a cloud native architecture. Right.
Not to say that I agree with the question necessarily, but that was the spirit of the question. Right? It's not because this is not a standalone. People were questioning whether it's cloud native.
Gotcha. I mean, yeah, like because it's a library, I guess is the.
Yeah. I think what was in the mind of people asking this question was, well, can I use it directly, or do I have to write a program to use it? And but I don't see. I mean, that's a valid question, right? And I think it should be made clear, but I don't see why that would qualify or disqualify you from being.
Yeah, that's sorry. I got a street cleaner going on out here. That's something I guess that we can't fix. If you guys don't want libraries in CNCF, like we're a library.
I'm not saying that. I'm saying that was what was in mind of the people asking the question. And I think we have to clarify if libraries are fine Trying to think if there's another CNCF project.
Yeah, that's what I was looking at. I was looking at the graduated ones. I think like, I don't know. Jaeger is sort of, it's its own thing. I don't know. I'd have to poke around a little bit and see.
Yeah, but let me get back to you on this. I wouldn't worry too much because, like you said, there's not much you can do anyway.
Yeah. It's sort of binary, right?
Yeah.
Which is fine.
I had a question for Vignesh. Back, if I heard you right on the compactor could be either part of the writer process or an independent writer process.
Yep.
Did I hear you right? So you could have, if I understand correctly, you could have the writer be somewhere on some availability zone where data is being generated, and then an S3 bucket being consumed in a different availability zone, and potentially run the compactor on that second availability zone where the data resides in the S3. Is that correct?
That kind of configuration is possible. Yes, that is correct.
Thank you.
Do you have a slide on performance? Like, I know it's a difficult question to ask because you're really dependent on the object storage, but just to get an idea.
I don't have a slide on the performance. This is growing very fast, and the performance numbers change very quickly. I had a slide and then I removed it. So
do you have any rough numbers, Vignesh, when you did? I'm assuming you did it against ABS.
Yes, I did it against Azure Blob Storage, and I did it with 100,000 keys. And I was able to get between 50K to 100K per second on the writes. This was a workload which had 50% reads and 50% writes. And the key size was 1 kilobyte, and the value size was around the same. Right, so that is the kind of write that I was able to get. And this is a run that I have not shared with everybody else and got feedback on. So that's why I did not include it in the slide itself. And this was also a single thread is what I used, right? So that's one number that I have. I think the bottlenecks for us is how fast we can write to object storage, right? And there is a knob, which is the flush milliseconds, that defines the batching. And object storages work well for large writes. They are very performant. So those are the numbers those are some of the things that I can share. I don't have a slide on the perf number itself right now.
Yeah, I can add a little flavor to some folks from Nile did some benchmarking as well, and they posted their charts in our Discord. But it's like very early days. I think we're in the make it work phase right now, not the make it fast phase. But I think we've hit, like 20 megs a second or something like that throughput wise. And then like Vignesh says, I think sort of in the 50 to 100K writes per second. On the read side, it's like, we haven't really perf tested that much because the caching helps so much there that like Vignesh said, the writes are pretty slow. So ballpark, I would say sort of 50 to 100K writes, 20 megs a second, something like that on a single thread is sort of like where we're at right now. So not amazing by any stretch of the imagination, but serviceable.
I see Marlo have a hands up.
Hi. One of the functions that I do in the ecosystem is I'm one of the tag chairs for the CNCF Environmental Sustainability Group. You may also go look, given the languages you're running, because Rust is a very low power use language, what the the actual power cost is later, maybe using Kepler or some other tool.
Sorry, I'm not super familiar with this. So Kepler is essentially a tool where we could benchmark it to see, like it's going to look at CPU cycles, and I guess it's going to have some stand-in for S3 in terms of power usage.
So Kepler is a power measuring tool. The one that is verified scientifically is Scafandra, but it's a little harder to use. And if you're going to do direct measurements with other like projects, you might prefer Kepler.
Okay.
It also does some modeling in cloud systems, which you don't get because you don't have bare metal access in most of the systems to your CPU readouts.
Oh, interesting. Okay, I see. It's sustainable computing data. Okay, this is interesting. I'm totally unfamiliar with it.
Yeah, it basically, if you look at a lot of the compute, especially when you start looking at AI, they're trying to figure out how to move a lot of the power into the AI systems. So the less power you're drawing for your particular program, the better, especially for infrastructure.
Is there any limit in the size of the value, I guess, in the key value store?
There is a limit. The limit is very high. I don't have it handy right now. Let me see.
Like are you depending on the underlying object store, or it's more your
Oh,
setup?
let's see. There is no limit essentially on the key size today. And on the object store layer, you can have the way these APIs work, or you can have large files that are several GBs. Let's say a key is very big. It will just be multiple IO requests to write that to the blob store, to the object store. And we don't have any limits today in the code itself.
So Vignesh, I think our block format enforces a 64K key limit, and I believe the value limit is like assigned in max. It's like, I think 2 or 4 gigs. I can't remember which. So there's sort of a key value limit that's imposed by the block format. The next level, as Vignesh said, is like the SST sizes on object storage, which is really just whatever the object storage is going to give us. And then the last one is sort of the memory pressure aspect with the manifest, because right now the manifest is stored in memory. So if you have like 100 billion SST files, like you might run out of memory holding all that manifest information. And so there's no hard limit except for the key value thing I mentioned and the object store, whatever they impose on us. But there's like soft limits or sort of practicality around the maximum number of SSTs, and you can control that based on your SST size and how frequently you compact. And so it's kind of a wishy-washy answer again, but like I believe Rohan from one of our committers tested it up to like 5 terabytes or something, and it was fine. The manifest was still relatively small.
Okay.
And will your manifest, does it need to be pinned, or can it roll into swap?
I'm not totally sure what you mean by that.
If you have a swap file for
okay, gotcha. Yeah, no, so it's a purely memory right now. We can't swap it to disk or anything, and so like that's where I think the memory pressure aspect comes in.
What would you like to see or what kind of help can the CNCF or the storage tag do for you to be successful?
So I think personally, I want a few things out of this. Like I would like to separate the project from me. I would also like to establish some governance. And so I know you guys don't have like a one-size-fits-all governance model, but some guidance on like what other CNCF folks are doing, what you see work well, I think would be super helpful. And then, I mean, practically speaking, like we have no performance test machines. So, I mean, Apache has infra. I don't know if you guys have any kind of infra, but that would be helpful. if you do any kind of like GitHub action pool or something. And then I think some of the publicity work that you guys do, getting the project more visible, I saw there were like at least a couple different avenues for that. I think would be good. One of them was like not use cases, but case studies. I think there was a blog thing as well. So it's publicity, getting more attention to it, I think would be good. And then I think in that vein, getting the other CNCF projects aware of it as like a viable option for, I mentioned Kine and etcd. I think there are potentially many other use cases, especially on like the observability side where you're dealing with large data and latency isn't as much of an issue. So sort of getting visibility within the other CNCF projects to see if we can collaborate on use cases with them would also be good. Sorry, I'm kind of rambling, but those are some of the top of mind things for us.
So the first thing I think I heard you say, you're looking to separate the project from you. I think that's a call for more maintainers. Is that, or a maintainer? Is that what?
Well, no. So we actually have pretty good engagement. I think we've got 5 maintainers. I would always, welcome more maintainers, but what I'm more talking about is like governance and being able to, establish sort of, how do we add new maintainers? When do we vote on a release? Who runs the release? How do we, what does the roadmap look like? More of the process stuff. I think guidance on that would be helpful, if that makes sense.
Yeah.
Because frankly, where we're at right now is I'm like, oh, I'm going to cut a release. And then I cut the release. And then I'm like, okay, do you guys think we should add a maintainer? And this guy's been contributing a lot. And then everyone's like, yeah, okay, well, let's do it. And it's very, at a certain point, companies are going to be depending on this, for their infrastructure. And we can't operate in that mode once companies are in production with this stuff and, it's being used heavily. So.
Yeah, getting these things into place is exactly the purpose of the graduation model of CNCF. So, yeah. I think we can at least point out what should be done, what should be, fixed. Then how we can certainly help you find examples.
Yeah, that sounds great.
Okay. Any other questions? All right.
Can you make your slides available to us?
Yes, I can do it. How do I drop a link in the chat? Is that?
That's fine.
Okay, I can do
Add
that.
the agenda doc.
Okay, great. I'll do that.
One other note is we're doing P99 Conf presentation later this afternoon. So if anyone's interested in talking more, I think mostly it's going to be on like chat, but there's another presentation that Rohan and I did, very similar to Vignesh's, but older. So there's more content if you guys are interested or want to talk more. Rohan and I will be there.
Okay.
Thanks, Vignesh. This was great.
Yeah. Thank you, Chris, for the presentation. I copied a lot of stuff from the P99 presentation, and I'd add a little bit more.
Yeah, no, this one's better. So this one's better. I like the intro a lot more than what we had too. It's good. Well done. We need to update the cache now. We need to update the architecture with caches.
Yes, I try to do it. The diagram is harder, so I put it as text. And thank you everyone from the CNCF tag group. Here are some pointers, and we think the documentation is good and it should be possible to test it out. If you have any questions, we also have a Discord. Thank you again for today.
Thank you.
Yeah,
Would
thank
you
you.
be able to put that link now, or
Oh,
later?
I see. Okay, let me.
Or you can put it in the tag storage. Slack channel 2, either way.
Okay. Sounds good. And okay, so there's the link.
Thank you very much.
Oh, it's saying that you need
Thanks,
access.
Essie.
Do you mind opening up?
Yeah.
Yeah. Vignesh, did you hear that?
Oh, sorry.
It's-
Don't have access. Yeah.
yeah, the access is locked down.
How do I share this?
I think if you can either open it up to viewers, anyone with link can view, or you can, we can hit the request access button if you want.
Okay, so I have not done this.
Your
Before.
Microsoft is showing. You need share.
Yeah, I tried to create this in how do I do this?
It's usually like in the upper right. Let me see if I can. Here, let me.
There's a share button on top.
There is a share button.
Yeah,
Okay.
you can click on
and
that. You can change
anyone
that.
with a link, got
Yeah.
it.
Right. At
Copy
least
link.
at least viewer so that we can at least view it.
Yep, I got it now. I can see it.
Yeah, works now. Thank you.
Awesome. Okay, well.
Yeah. Wasn't that hot. Okay, again, thank you all. Bye.
Yep. Bye.
Thank you. Bye.